Start the recording. So here the position of ST and VT are given, and first you have to draw the XY line, and after that you are drawing the first end projector. Then you are locating ST and VT by drawing vertical and horizontal projectile, so that you will get ST here and VT here. Then you have a vertical projector line, and it is meeting the XY line here. You can name it as small h, and this is the position where the elevation extended is meeting the XY line, and this is VT. What is small v? Small v? Small v is the position where the plan extended is meeting the XY line. Then what next? Let us return to our previous example. So we got the position of the elevation extended meeting the XY line and the plan extended meeting the XY line. Let us return to our one of the previous problem. So this is our small h, this is our small v. Then what next? Here we got small h and small v. Then you consider this line. If you draw a line from VT to ST, and if you extend that line, then our elevation will be on that line, isn't it? Here we obtained small v and small h. This point and this point are obtained. Then what next? We know the position of capital V or vertical trace. If you connect VT and small h by means of a straight line, and if you extend that line, then we can say that our elevation will be on that line, because for drawing vertical trace we are extending the elevation to intersect this vertical projector. So you are proceeding in the reverse direction. Here we have VT and small h. We will join small h and VT by means of a straight line, and we will extend like this, so that our point A and B will be on this line. So let us return to our problem. So here we obtain small v, small h, capital VT and capital HT. What next? You can join VT, that is small the vertical trace, and the small h. Here, should be small h. You are joining these 2 points together by means of a straight line, and we are extending that line. And we can say that our point A and B will be on that line extended. So that is done in the next slide. You see this. You are connecting VT and small h by means of a thin line, and you are extending that line. And this line extended is intersecting the first end projector here, isn't it? And that point is our A dash. Any doubt in this? We are proceeding in the reverse direction. Any doubt?
No, sir. No, sir.
Okay. So VT and H are connected using a straight line. We are extending that, and it is intersecting the first end projector here. That is marked as A dash. Similarly, VT, the horizontal trace ST and the small v can be connected. You see the previous example. in the previous example, you see this. VT is obtained by extending the here you see this. The plan is extended to the horizontal trace, extended, and here it is meeting this vertical line, and that is our horizontal trace, and it is meeting the XY line here, and that is small v. And if you join small v and HT, you will get this line, and if you extend that line, then you can say that a point small a and small b will be on this line extended. So let us return. Here we have small v and HT. We will be joining this using a line, and we are extending like this. And if you extend this line, it will intersect the first end projector here, and that is our small a. So here we will get a dash, and here we will get small a. So locate a dash and a. Any doubt here?
No, sir.
Okay. So have you obtained a dash and a? Alvin Febi.
Yes, sir.
Have you obtained a dash and a?
Yes, sir.
Then Hanna.
Yes, sir.
Have you obtained a dash and a?
Yes, sir.
Any doubt here?
No, sir.
We are proceeding in the reverse direction. Leah Kia.
Yes, sir.
Any doubt? Is it clear? Yes or no? Okay.
Yes, sir.
Okay. Mohammed Rasi.
Yes, sir.
Any doubt here?
No, sir.
Okay. So we obtain the position of A dash and A. Then what next? In the question, it is given that the elevation length is 50 mm. So you can mark that. Here we obtain the position of A dash. You take 50 mm in your compass and intersect on this. Here we haven't obtained this end, isn't it? So for that, you take 50 mm in your compass and with the A dash as center, intersect on this line so that you will get the position of B dash. Do it. Take 50 mm in your compass because it is given. The elevation length of the line is given 50 mm. So take 50 mm in your compass and with the A dash as center, intersect and obtain the position of B dash. Have you obtained B dash? Pranav?
Yes, sir.
Have you obtained B dash? Hurry up. Sri Shankar, have you obtained B dash? Gautam Krishna, വരച്ചു കഴിഞ്ഞോ?
കഴിഞ്ഞു.
ദേവിക,
Sir.
yeah, have you finished?
No.
Yeah. Have you obtained B dash? Susan Maurice?
Yes, sir.
Have you finished?
Yes.
Okay, so we obtained the elevation of line AB. Here we have A dash, here we have B dash. Then we have to complete the plan. Here you haven't obtained the position of B. How will you obtain B? Through point B dash, you erect a vertical projector. Here we obtain the position of B dash. Erect a vertical projector like this. And this projector line will intersect this inclined line at a point. And that is our small b. So do it. After locating B dash, erect a perpendicular, that is our second end projector. This is our first end projector, and here we are drawing the second end projector. The second end projector is drawn through point B dash, and it is coming like this, and it is intersecting this inclined line here, and that is point small b. Do it. Finish?
Yes, sir.
Okay. So we obtain the elevation and the plan. Our next step is obtaining its true inclination and true length. Here you have to find the true length and the true inclination. Here line AB is inclined to HP and VP. So it will not reveal its true length in both plan and elevation. It will not reveal its true length in elevation and will not reveal its true length in plan. Now, first of all, let us find the true inclination of the line with respect to VP. If line AB is parallel to HP, then in the plan it will reveal its true length and true inclination with respect to VP. So let us make this line A dash B dash parallel to VP. So that is done in the next slide. I am moving to the next slide. So you take this radius in your compass. It's 50 mm. Take radius A dash B dash in your compass and with A dash as center. So before that you have to draw a horizontal line from A dash to the left hand side like this. So draw a horizontal line from A dash like this. A thin horizontal line from A dash. Draw this horizontal line. We are making it parallel to HP. So after drawing that horizontal line, you take radius A dash B dash and you are drawing an arc like this with A dash as center, drawing an arc and intersecting this horizontal line here. We are making it parallel to HP. So it will intersect here, and that point can be marked as B1 dash. Have you obtained B1 dash?
Yes, sir.
Okay. So if you are making it parallel to ST, what will happen to point B? Point B will move along the locus plane. If you are making it parallel to ST, then B will move along this horizontal line. This horizontal line is our locus line. So at point B, you draw a horizontal line like this and name it as locus of B. So what is the specialty of locus line? If you are making it parallel to B, parallel to HB, then B will move along this plane. So this line can be marked, and after obtaining B1 dash, draw a vertical projector and intersect the locus plane, so that you will get the position of B1. So draw the locus line through point B. Then erect a perpendicular from B1 dash and intersect the locus plane here, and that is point B1. Have you obtained B1 dash and B1?
Yes, sir.
Jewel Davis,
Yes, sir.
have you obtained B1 dash and B1?
Yes, sir.
What is the true length of line AB? You can measure AB1, that will be the true length. Here, line A dash B1 dash is parallel to ST, so AB1 should give the true length. What is the true length of line AB1? Jewel. You can measure that. You have completed this. Cindy,
6 centimeter. 5.86.
5 point?
5.8 centimeter. 58 millimeter.
You have to answer the true length in mm. What is the length?
58.
58 mm. Fatima, can you hear me? What is the length? AB1.
59.
Okay, it's okay, no problem. Neeraj Jayprasad,
Yes, sir.
have you obtained AB1?
Yes, sir.
What is the value of phi? Here, you can measure that angle phi. What is the value?
27.
27 degree.
Yes, sir.
Sandra Sadishan,
Yes, sir.
what is the value of phi?
28.
28 degree.
Yes, sir.
Sri Ranjini,
Sir,
what is the value of phi?
27.
20?
27 degrees, sir.
27. Okay. So you have obtained the true length and true inclination of line with respect to BP. True length is around 58 mm and phi is around 27 or 28 degree. Now what next? We have to find the true length of the true inclination of line with respect to the horizontal plane. How will you find that? For that, you have to make line AB parallel to the vertical plane. If a line is parallel to the vertical plane, then in the elevation, it should reveal its true length and true inclination with respect to SP. So for that, first you will draw a horizontal line from point A, like this horizontal line. We are making line AB parallel to the vertical plane. Draw this horizontal line. Must be a thin line. Then at point B dash, you can draw a horizontal line like this, and you can name it as locus of B dash. So draw these two horizontal lines. One through point A, the other is drawn through point B dash. This line is our locus of B dash line. Have you finished this? Have you finished this? Can I proceed?
Yes, sir.
Sir.
Okay. Then what next? Here, this is our line AB. You take that radius in your compass. Take radius small ab in your compass, and with A as center, draw an arc and intersect this horizontal line. And you can name it as point B2. So obtain B2 by drawing this arc. Have you obtained B2? Can I proceed?
Yes, sir.
Okay. Then what next? If you are tilting, if you are making line AB parallel to VP, then what will happen to point B dash? Point B dash will move along the locus plane. If you are making it parallel to VP, then B dash will move along the locus plane. Let us locate the position of B2 dash. For locating B2 dash, you are drawing a vertical projector from B2 like this. And this projector is intersecting the locus of B dash line here. You mark that intersection and name it as B2 dash. So obtain B2 dash and connect A dash B2 dash by means of a straight line. Obtain B2 dash by drawing a vertical projector, and the intersection is marked, and you have to connect A dash B2 dash. Alvin Febi. Alvin
Yes, sir.
Febi.
Yes, sir.
Have you obtained B2 dash?
Yes, sir.
Have you connected A dash B2 dash?
No, sir.
You connect A dash B2 dash. Okay. Then, Alvin, what is the length of A dash B2 dash? What is the length of line A dash B2 dash?
60 mm.
60 mm. That is wrong. That is wrong. I think you are not drawing these examples. It's very clear.
No, sir, I have drawn.
That value is wrong. You are not drawing these examples. It's very clear. Arun Syriac. Arun Syria.
Sir, 56.
66.
56.
56. Sri Shankar.
Yes, sir.
What is the length of A dash B2 dash?
55.
55. What is the length of AB1?
55 something.
Susan Varghese. Susan Varghese.
Yes, sir.
What is the length of AB1? First you
50.
measure
58 millimeter.
58 mm. Okay. What is the length of A dash B2 dash?
57.
57. That is okay. So here A dash B2 dash and AB1 will give the true length. So these two must be almost same. 1 or 2 mm variation is tolerable. So here the true length is approximately 58 mm. And Mr. Najmal,
Yes, sir.
what is the, have you completed this?
Yes, sir. Completed.
What is the value of theta?
46 degrees.
46 degree.
Yes, sir.
Okay. Namita and Peter,
Yes, sir.
what is the value of theta?
52.
52.
Yes.
Sri Lakshmi,
Sir,
what is the value of theta?
46.
46. Misaj,
Yes, sir.
what is the value of theta?
48, sir. 48 degree.
48 degree. Khanna, what is the value of theta?
47 degrees, sir.
Okay, it's around 47 or 48 degree. Okay, so 1 or 2 degree variation is tolerable. So that is the true inclination of line AB with respect to ST. Phi is the true inclination of line with respect to BP, and theta is the true inclination of line with respect to ST. So that is the solution. Here, after this, what is the final step? You have to mark the dimensions. Here, the given dimensions should be marked. Here, the position of ST and VT are given. That dimensions should be marked. The length of line A dash B dash is given. This inclined dimension is given. It should be marked using an inclined arrowhead. This dimension A dash B dash is 50 mm. That should be marked in your drawing. Then, what are the parameters that you have to find out? That is the true length, theta and phi. These parameters should be shown at the top right hand side in a rectangular box. TL is equal to, then you have to write the value. Theta is equal to, then phi is equal to. That should be enclosed in a rectangular box, and that is your job. You have to complete that. And while submitting this assignment, it should be here. Okay, this your notebook will be an assignment. You have to show that. So it's up to you. You have to complete that. So I am proceeding to the next problem. Any doubt in this example? Any doubt in this example? Can I proceed?
Yes, sir.
Okay, I am proceeding to the next example. That is a special problem. You take care of this one. The midpoint of a line AB is 50 mm above ST and 30 mm in front of AB. The line measures 80 mm and is inclined to ST by 45 degree and 30 degree to AB. Draw the projections. Have you completed the question? Have you completed the question?
Yes, sir.
Okay, so here we have a midpoint problem. Here the midpoint of a line is given. The midpoint of line AB is 50 mm above ST and 30 mm in front of it. The true length is given. Inclinations are also given. We have to draw the projection. So I am presenting my 3D window. Can you see the 3D window?
Yes, sir.
So here, this is our line. And in the previous examples, we were tilting the line with respect to one end. See, we are pivoting the line at this point, and we are pivoting and we are moving the line, pivoting this end. But here, the midpoint is given. That means we have to tilt the line, pivoting the midpoint like this. So here, consider that the line is making 45 degree inclination with respect to ST. First, we will assume that the line is parallel to ST and VP. Then what next? After this, we will tilt the line with respect to ST. Here in the question, it is given that the line is inclined to ST by 45 degree. So let us tilt the line with respect to ST by 45 degree. So I am tilting the line, pivoting the midpoint. So tilting like this. Now it is around 45 degree. So this is our first projection. So here the line is parallel to VP and inclined to ST by 45 degree. We are tilting the line, pivoting the midpoint, not the first end. Now, after that, in the question it is given that it is inclined to VP by 30 degree. So we have to ultimately tilt the line, pivoting the center point by 30 degree with respect to the vertical plane. So like this. So the final projection will be something like this. It is making 45 degree inclination with respect to ST, and it is making 30 degree inclination with respect to the vertical plane. So any doubt in this? Any doubt? Here, the change is the pivot point. In this problem, we will be tilting the line, pivoting the midpoint. The position of end A and B will be changing, but the midpoint will remain at the original position. First, we will tilt with respect to HP, and then we will tilt with respect to VB. But the position of point M remains the same. That is the physical explanation. Any doubt here? So I am proceeding to the PowerPoint window. I have to finish within 30 minutes. Can you see the PowerPoint window? Can you see the PowerPoint window?
Yes, sir.
Okay. So first you draw the XY line. Draw the XY line. And after drawing the XY line, towards the center, you draw a vertical projector line. Like this. Draw the XY line, and towards the center, you draw a vertical projector line like this. Have you completed this? Have you drawn the XY line and drawn this vertical projector?
Yes, sir.
Then we have to mark the position of the midpoint. Here in the question it is given that the midpoint of line AB is 50 mm above SP and 30 mm in front of B. Let that point be small m. So let us mark the position of the midpoint on this vertical projector. Let that point be M. So M dash, the position of M dash, it is 50 mm above SP. So on this vertical projector, after leaving 50 mm, you have to mark point M dash. This distance must be 50 mm. You are marking the position of the midpoint, and we will be naming this point as M dash. Similarly, here, after leaving 30 mm, you are marking point small m. Here, M dash is the elevation and M is the plan. This distance must be 30 mm. It is given in the question. Have you marked M dash and M?
Yes, sir.
Then, so this is the midpoint of line AB. First, let us assume that the line is parallel to SP and VP. So, if it is parallel to SP and VP, then it will appear as a parallel line in the elevation and in the plan. So, here we have got the position of the midpoint. So, you draw a horizontal line through point M dash and another horizontal line through point M, so that you will get these two lines. Have you drawn that horizontal lines?
Yes, sir.
Okay, then here we are assuming that the line is parallel to SP and VP. If a line is parallel to SP and VP, then what are the specialties? It should reveal its true length in the elevation and in the plan. The true length of the given line is given, isn't it? The line measures 80 mm. True length is 80 mm. You know the midpoint of line AB. So, can you locate A1 dash and B1 dash? Can you locate from this data? Can you locate A1 dash and B1 dash? Namita?
Yes, sir.
Can you locate A1 dash and B1 dash? You know the midpoint, you know the true length, then can you locate A1 dash and B1 dash?
By
You know the midpoint, you know the total length, then can you locate A1 dash and B1 dash? It's very simple. ഇതിന് ഇയാൾ ആൻസർ പറഞ്ഞില്ലെങ്കിൽ ഇയാൾക്ക് ഗ്രാഫിക്സിന് യാതൊരു ഉപയോഗമില്ല.
sir, just measurement എടുത്താൽ പോരെ? Midpoint ആകുമ്പോ സൈഡിൽ
A1 dash and B1 dash. Then, so I proceed to another person. Noel Bailey.
Yes, sir.
So, how will you locate A1 dash and B1 dash?
Sir, midpoint in 40 mm.
Okay, that is it. Take 40 mm in your compass. Take 40 mm in your compass, and with the M dash as center, intersect here and here, so that you will get A1 dash and B1 dash. Take 40 mm. So what is 40? Why it is 40 mm? 80 divided by 2, because M is the midpoint. Take 40 mm in your compass and intersect here and here, so that you will get A1 dash and B1 dash. The same thing can be repeated here with M as center, intersect here and here, so that you will get A1 and B1. So locate A1 dash, B1 dash, and A1 and B1. And that is the line when it is parallel to HP and V. So I am proceeding to the next slide. Have you finished this? Have you finished this? Okay. Now I am tilting this line with respect to HP, keeping it parallel to V. So I'm moving to the next slide. The inclination with respect to HP is given this 45 degrees. So here we have M dash. Through point M dash, you have to draw a 45 degree line. If a line is parallel to VP, then what is its specialty in the specialty of that line? It should reveal its true length and true inclination in the elevation. Here we are keeping line AB2 parallel to VP. So in the elevation, it should reveal its true length and true inclination. So how will you draw this? Through point M dash, you draw a 45 degree line of sufficient length. We don't know the exact position of A2 dash and B2 dash. We will mark it later. Draw a thin 45 degree line through point M dash. We are tilting the line, pivoting point M dash. Here the pivot point is M dash. The position of A and B are changing. Have you drawn the 45 degree line? This 45 degree line.
Yes, sir.
Okay. Then you take radius 40. What is 40? 40 is the half of 80 mm. 80 is the true length. You take the half of that, that is 40 mm. Take 40 mm in your compass and with M dash as center, draw an arc like this and intersect the 45-degree line at A2 dash. Draw this arc, intersect here, that is A2 dash. Similarly, keeping the same radius in your compass, you can draw another arc from B1 dash and intersect the 45-degree line at B2 dash. So you will get A2 dash and B2 dash. This is the condition where the line is inclined to SP by 45 degree and parallel to BP. So making it inclined to SP by 45 degree. So you will get A2 dash and B2 dash. Then here through point A2 dash you can draw a thin horizontal line and you can mark it as locus of A dash. You can draw this thin horizontal line here. And another thin horizontal line through point B2 dash, and you can name it as locus of B dash. This slightly complex problem. So after that, from point A2 dash, erect a perpendicular and intersect A1, B1 at point A2. Draw another vertical projector and intersect line A1, B1 at point B2. So what is the speciality of A2, B2? A2, B2 is the plan length of line A2 dash, B2 dash. Here the line is inclined to SP by 45 degree and parallel to BP. So in the elevation, it is revealing its true length and true inclination. But here it is giving only its plan length. And the plan length is A2, B2. Have you obtained A2, B2?
Yes, sir.
Lakshmi G. Menon.
Yes, sir.
Have you obtained A2, B2?
Yes, sir.
Okay, so that is the plan length of line AB. Then let us proceed to the next slide. Then in the next slide, we will assume, we will consider the other condition. We will tilt the line with respect to VP, keeping it parallel to SP, so that in the plan it is revealing its true length and true inclination, and in the elevation you will get the elevation length. So that is done in the next slide. We will tilt the line with respect to VP, keeping it parallel to SP. So here, through point M, you draw a 30-degree line like this. Through point M, draw a 30-degree line. Lakshmi, have you completed this 30-degree line?
Sir,
Draw a 30-degree line of sufficient length. For the time being, you can't mark the position of A3 and B3. There must be sufficient length. It must be a thin line. Is it over, Lakshmi? Is it over?
Yes, sir.
Okay. Then take 40 mm in your compass. What is 40 mm? 40 mm is the half of 80 mm. Here we are assuming that the line is parallel to ESP. So in the plan, it should reveal its true length. So take 40 mm in your compass and with M, that is the midpoint as center, you are drawing an arc from A1 and intersecting this 30-degree line here, and that is point A3. Similarly, keeping the same radius in your compass and with the M as center, from point B1 you are drawing another arc in the opposite direction and intersecting this 30-degree line here, that is point B3. So you will get A3B3. A3B3 is the condition where the line AB is making 30-degree inclination with respect to SP and 30-degree inclination with respect to BP and parallel to SP. Gauri, Govind,
Yes, sir.
have you obtained A3 and B3?
Yes, sir.
Okay. So after obtaining A3 and B3, in the plan, you can project upwards. And obtain the position of A3 dash and B3 dash. So draw a vertical projector like this, and another projector like this. Here it will intersect A1 dash, B1 dash, here and here. And that is A3 dash and B3 dash. Obtain A3 dash and B3 dash. And that is the elevation length of line AB. Ashwini Kumar. Ashwini, yes.
sir.
Have you obtained A3 dash, B3 dash?
Yes, sir.
Okay. So that is the elevation length, the apparent length in the elevation. So we have obtained the plan length and we have obtained the elevation length. Then here at point A3, you have to draw a horizontal line like this, and that is the locus of small a. So draw this thin line, that is locus of small a. Similarly, at point B3, draw another horizontal line like this and name it as locus of small b. Draw this locus lines. And this is the locus of A dash and this is the locus of B dash. Here we have locus of small a and here we have locus of small b. Draw the locus lines. Have you completed this?
Yes, sir.
Kajal?
Yes, sir.
Have you completed the locus lines?
Yes, sir.
Okay. So let us proceed. Then, here, consider the plan. Here we have the locus of small a. Here we have locus of small b. Now we know the plan length the plan length, the apparent length of the line AB in the plan is obtained. That is AB2. That is obtained from the previous drawing. We know the plan length. So you take MA2. What is the length MA2, Kajal? What is this length? MA2. What is this length?
Uh, 28 millimeters.
20?
millimeters.
28 mm. Hanna Saha.
Yes, sir.
What is the length of MA2?
Yes, sir.
What is the value?
28.
Okay.
29 millimeters.
Okay, that's all right. So take MA2 in your compass and with M as center, draw an arc and intersect this locus line. Because we know that if you tilt the line with respect to HP, point A will move along this line. So, and we know that this is the radius. Here, point M is fixed. We know the plan length. So you take the half of the plan length, that is MA2, and you are drawing an arc starting from A2 and intersecting this locus line here. And we will mark it as small a. Similarly, you can keep the same radius in your compass, and that will be equal to MB2. You can draw another arc in the opposite direction and intersect this locus line here, and that is small b. We are drawing the first arc from A2 and intersecting this locus line and marking it as small a, and you can keep the same radius, that is MB2. MB2 is equal to MA2. So MB2 as radius, you can draw this arc and intersect the locus line here, that is small b. Connect AB, and that is the final plan. Do it. Hurry up. You have to finish within 5 minutes. Edwin Thomas. Edwin Thomas. Edwin Thomas. Have you drawn AB?
No drawing, sir.
So all of you mark your attendance by sending a chat message. Mark your attendance by sending a chat message. So here we obtained the final plan of line AB, that is small AB. Now what next? We have to mark the elevation. How do you mark that? For that, you can draw vertical projectiles from point small a and small b. So from point small a, draw a vertical projector, and from small b, draw another vertical projector. So I'm moving to the next slide. So here you are drawing a vertical projector from small a like this, and another vertical projector from small b like this. Jyotika,
Yes, sir.
have you drawn the
Yes.
projectors?
Yes, sir.
Mute your audio. Arya, see. Arya,
Yes, sir.
have you drawn the projectors?
One more line, sir.
Okay. So if you draw the projectors, here you are drawing projector from small a, then it will intersect the locus of A dash line at a point, and that can be marked as small a dash. Then you consider the next end projector that is drawn from small b. This projector line will intersect the locus of b dash line at a point, and that can be named as small b dash. So we obtained a dash and b dash. Connect a dash b dash by means of a straight line, and that is our elevation. Projector line is meeting locus of A dash at point A dash. This projector line is meeting locus of B dash at point B dash. Connect A dash B dash. That is the elevation of line AB. Shreya Biju,
Yes, sir.
have you obtained the position of A dash and B dash?
Yes, sir.
Okay. Then Arun Syriac,
Sir, yes, sir.
have you obtained A dash and B dash?
Yes, sir.
Okay. So I'm proceeding. So we have obtained the projections. We have to make sure that it is correct. So you take your compass and take radius m dash a dash. Take radius m dash a dash in your compass and draw an arc and make sure that it is intersecting a3 dash. Take radius m dash a dash, m dash a dash in your compass, and with m dash as center, you are drawing an arc and making sure that it is passing through a3 dash. Similarly, take radius m dash b3 dash, draw an arc and make sure that it is b3 dash. Is it passing through A3 dash and B3 dash? Mr. Anthony Paul?
Yes, sir.
Okay. So that is the solution. We will meet in the next class. And you can leave now. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.